So this is the second video in which we are going to solve previous year questions of matrix and determinant. So in first video we have completed up to question number 4. Now we are starting. Actually the questions written here, it is wrong. That's why I have written this is the exact equation which is given in the question paper of 2023. But if you find a square and put it, then you will not get at a null matrix. Okay, so the correct equation will be a square minus 4a minus I, which is identity matrix. Since A is also a 2 by 2 matrix, we are considering I is also a 2 by 2 identity matrix. Okay, so considering this equation, we are going to solve this particular question. So since we have in the left hand side a square, so first we have to calculate a square. So to calculate a square is nothing but a multiplied by a. So a is 3, 2, 2, 1. Again it is multiplying with 3, 2, 2, 1. If we have a matrix multiplication, it is 3 3s are 9, 9 plus 2 2s are 4. Same. 3 2s are 6 plus 2 1s are 2. Similarly, 3 2s are 6 plus 2 1s are 2, and then 2 2s are 4 plus 1 multiplied by 5. So ultimately our a square is 13 plus a. Here it will be a 8, here 5. Okay. Now to prove this equation, taking left hand side. So left hand side it is a square minus 4a minus I. So what is a square? A square is 13, 8, 8, 5. And the value of minus 4a. A is nothing but 3, 2, 2, 1. Minus identity 1, 0, 0, 1. Okay. So the calculations become 13 minus 4 into 3, which is 12. 4 into 3, 4 will be multiply with each of every elements of that matrix. So 3 4s is 12 minus 1. Similarly for 8, 8 minus 4 2s are 8 minus 0. Then 8 minus 8 minus 0. Then here 5 minus 4 minus 1. So clearly this matrix is 0, 0, 0, 0, which is nothing but null matrix, bold O. So hence our equation is proved. So we can write proof. This is our first portion of that particular question. Now we have to calculate A inverse from that equation, that is using that equation. Now we are going to calculate A inverse. So till now what we have a square minus 4a minus I is equals to a null matrix. That means a square is a null matrix plus 4a plus I. So if you add null matrix with any matrix, you will get the same matrix as like 0. So a square is nothing but 4a plus I. Now actually we are going to multiply the equation by A inverse. See, in case of matrix multiplication, when we are multiplying with A inverse, since I've written left hand side, actually left multiplication AB is not equals to BA. So since in left hand side we are also multiplying A inverse in the left side of A square, so in that case also we should apply this one. It will be A inverse I. Remember, you can't write A inverse, so it will be A. It is of 4 A inverse A is actually identity matrix. You can say A inverse is the reciprocal of A. Or the main thing is, since I is identity, that means A, if you multiply A with A inverse, you will get identity matrix. Okay, that is the concept. So identity multiply A inverse, it will be A inverse. So see, from that it is clear A inverse is equals to A minus 4i. So now from that we can easily calculate. Our A is, I think, 3 2 2 1, 3 2 2 1, that is 4 multiplied by identity matrix, which is 1 0 0 1. So it is 3 minus 4 into 1, 2 minus 4 into 0, 2 minus 4 into 0, 1 minus 4 into 1. It is 3 minus 4 means minus 1. It is 2 minus 0 is 2. Now 2 minus 0 is also 2. 1 minus 4 is minus 3. So that is our A inverse. After this, move to our next question. This is question 6. Here also we have to calculate A inverse, but in this question we are going to calculate A inverse using the formula of adjoint A by determinant of A. See, to find A inverse, this determinant cannot be 0. Okay, cannot be 0. That means the matrix A should be a non-singular one, non-singular matrix. So to calculate A inverse, we should always check first its determinant, whether its inverse exists or not. So determinant of A, det A, we can write that way, or we can write determinant of A. It is nothing but one determinant symbol, minus 1 1 2. 2 into 1, that is minus 1 into minus 1, which is 2 minus 2 plus 1, which is 3. So since it is not equals to 0, so we can calculate its determinant. Now is the process of finding adjoint A, okay, because it is adjoint A by determinant of A. Now what will be adjoint A? Adjoint A is actually, first we have to find the cofactor of all these three. Okay, so let me write in a simple to find adjoint A. First we are finding cofactor of 1. See, to calculate cofactor of 1, it will be, its position is 1 1. Okay, so there is a positive symbol. Okay, or simply you can memorize by in that way. Okay, the symbol is decided by its position 1 1. So 1 plus 1 2, it is minus 1 to the power 1 plus 1, which is a positive 1. So leave it, you just take this one. Using this you can easily find what is. Okay, so cofactor of 1 is nothing but these two. Similarly, cofactor of minus 1 is actually, for this place we have a minus symbol. Okay, minus symbol, and that if you remove this corresponding row and column, you are getting this element 1. Okay, so for minus 1 our cofactor is 1 minus symbol will be there inspiring from this, and this is our element, the minus of that element, which is minus 1. Similarly, cofactor of 1, that means that one. Okay, which position is, we can write also in that way. Okay, like in position, position cofactor of, or no problem, we can take this one. For this one, it will be a negative symbol minus of corresponding row and column cancel, we are getting only minus 1. Okay, so 1 it is minus 1, it is 1. So cofactor of 2, remember don't mix this 1 2, okay, this 2 times I have written 1, 2, the cofactor is corresponding row and column cancel, we are getting this 1. Okay, so there is a positive symbol, so 1. So now what will be our adjoint A? Adjoint A is nothing but the cofactors of all that one. First in that A we have 1. So what is cofactor of that one? It is nothing but 2. So you should write 2. Similarly cofactor of that minus 1, it is minus 1. For 1 it is 1, and for 2 it is 1. Okay, for 2 it is 1, and then we should take a transpose of that one, then we will get adjoint A. So if we take transpose, adjoint A is nothing but a cofactor of each and every element, and then we should take transpose of that matrix. So 2 minus 1, after taking transpose it will be like that. Okay, this is our adjoint A. Now what is A inverse? A inverse is actually adjoint of A by determinant of A. So how to calculate? Our adjoint of A is 2 1 minus 1 1, 2 1 minus 1 1, and our determinant is 1 by 3. Okay, determinant is 3 since it is a fraction, so 1 by determinant of A into adjoint of A. So this is our determinant is 3. Okay, fine. So what is A inverse? A inverse is, if you multiply you will get 2 by 3, 1 by 3, minus 1 by 3, and 1 by 3. This is our A inverse, which is our answer. Okay, now let's move to next one. This is one kind of important questions where we are going to find the solution of this system of linear equations using Cramer's rule. Okay, this is very simple one. If you know how to calculate determinant, then it is very easy. So let me write the quick steps. Writing so much things. Okay, we'll calculate del. Okay, so how to calculate del? Del is nothing but, if you take the coefficients of this x, y, z, and you forming a matrix. Okay, like 2 3 1 1 minus 1 1 3 2 minus 2. Okay, these are del. Actually these equations can be written as in that way: 2 3 1 1 minus 1 1 3 2 minus 2, and if you multiply with a column matrix x y z, you will get this one. Okay, this thing can be written as this, exactly same thing in the matrix form you can written like that. So del is nothing but that matrix. Now del is nothing but matrix, not matrix. We have to take the determinant also. We are calculating the determinant form is known as del. So let's calculate the determinant. For your understanding, I am writing, I am breaking each and every step. If you take 2 for corresponding 2 cancel corresponding row and column, you are getting minus 1 1 2 minus 2. Then if you take that's 3, okay, in that place what it is written 3 and 2. Okay, if you take 3, for 3 there is a minus symbol, since just like before, plus minus plus, alternatively plus minus plus minus plus. Okay, so minus 3 is 1 1 3 minus 2. plus 1. For 1, if you cancel this corresponding row column, you are getting 1 minus 1, 3, 2. 1 minus 1, 3, 2. Okay. This will be minus 1 multiplied by minus 2, it is 2 minus 2. Okay, that's at 2. Minus 3 into minus 2 minus 3 plus 1 into 2 minus 3, which is plus 3. Okay, so our del is 0 minus thrice of minus 5 plus 1 into 5. Okay, so that case we are getting 15 plus 5, which is 20. Is it right? Correct? Okay. Now we have to calculate del 1. What is del 1? Del 1 is nothing but if you replace this column with the first column, okay, in that matrix, that means 17, 3 and 4, and then 3 minus 1, 2, 1, 1 minus 2. Okay, sorry, again I have put the symbol of determinant, put determinant symbol. Okay, now we have to calculate del 1. So what is del 1? Del 1 is 17, 3, 4, then 3 minus 1, 2, 3 minus 1, 2, sorry, another column is there, 1, 1 minus 2, 1, 1 minus 2. Okay, so if we calculate, it will be 17 minus 1, 1, 2 minus 2, minus 3, it will be 3, 1, 4 minus 2, plus 1, plus 1, 3 minus 1, 4, 2. Okay, then into minus 1 into minus 2, it is 2, 2 minus 2 is 0. Minus 3 into minus 6 minus 4 plus 1, 6 plus 4, it is 0 minus plus 30 plus 10, which is 40. So similarly, we have to calculate del 2. Del 2 is nothing but if you replace in that matrix just second column by this one. Okay, so 2, 1, 3 will remain same, 2, 1, 3, then second column is will be 7, 3, 4, sorry, 17, 3, 4, then 1, 1 minus 2, 1, 1 minus 2. Now as usual, calculate 2, it is 3, 1, 4 minus 2 minus 17, you are getting that 1, 1, 3 minus 2 plus 1, 1, 3, 3, 4. After that, you will get 2 minus 6 minus 4 minus 17 minus 2 minus 3. Okay, minus 2 minus 3 plus 4 minus 9, 1. Okay, so in that case we are getting twice of minus 10 minus 17 into minus 6 plus 1 multiplied by minus 5. At last it is minus 20. It is going to be which one? And that 6, no? 7, 3, 4. Okay, is it correct? 1, 3, 1, 4 minus 2. Okay, 1, 3, 3, 4, 1, 1 minus 2. Okay, okay. There is something wrong. Minus 2. Okay, so minus 2 minus 3 is minus 5. Okay, so our calculation is going to be like that. It will be 17, sorry, it will be minus 20 plus 17 into 5 is 85. Now minus 5. It is actually how much? 60, na? Okay, 60. Now we are going to calculate our del 3. So how del 3 will be calculated? Del 3 will be calculated just replacing by the third column. So first two column as it is 2 1 3, 3 minus 1 2. Okay. So we are calculating del 3. What will be del 3? 2 1 3, 2 1 3, 3 minus 1 2, 2, in that case it will be 17 3 and 4. Now as easily we can calculate also 2, it will be minus 1 3 2 4 minus 3 into it will be 1 3 3 4 plus 17 into 1 minus 1 3 2. So it is going to be twice of minus 4 minus 6 minus thrice of 4 minus 9 plus 17 multiplied by 2 plus 3. So it is minus 20, it will be plus 15 is 85. So ultimately it is 80. Okay. So clearly now the value of x is nothing but what we have calculated till now. Del calculated 20, del 1 is calculated which is 40, del 2 is calculated 60, and now we have calculated del 3 which is 80. See, it's very simple. To find the value of x, it will be just del 1 by del, okay, which is 40 by 20. There are some conditions for consistent and inconsistent solutions, but here we don't need that concept, since the system of linear equations here is consistent. That means it's solvable, where we can find its solution. Okay. So that's why we're calculating. It will be 2. Y is del 2 by del, which is 60 by 20, which is 3, and z is nothing but del 3 by del, which is 80 by 20, which is 4. Okay. So now the solution is x equals to 2, y equals to 3, and z equals to 4. Now we can move to the next question. Similarly, here also we have to calculate one del. You try yourself. 2 minus 1, 1, 1, 2, 3, 3, 1 minus 1, and then you have to calculate del 1 by replacing that first column by 6, 3, 4 minus 1. Sorry, again I have written that matrix symbol. It will be determinant symbol. Okay. So minus 1, 2, 1, 1, 3 minus 1. Okay, from that you calculate that value. You should calculate that value also. So del 2 will be that 2, 1, 3 same. Second column will be replaced by 6, 3, 4, 1, 3 minus 1. Okay, and del 3 will be third column being replaced with 2, 1, 3 same, minus 1, 2, 1 same. You just have to be 6, 3, 4. After calculating, the value of x is going to be del 1 by del, y is going to be del 2 by del, and z is going to be del 3 by del. That's all. Okay, try yourself. If you face any problem, let me know. This is the problem where we have to prove that one. It is a determinant. Now actually we are going to use the properties of determinant. If you are going to apply a formula, that is how determining is being calculated, it will be lengthier, or sometimes it's not possible to prove that one. B square. See, in proof they told us to return B minus C, C minus A, and we will get that one if we subtract from column 2 to column 1. Okay, so column 1 is same, we are applying no column 2 to B. We should subtract this first row, second row from the first row, then we will get A minus B. Okay, so I'm writing, see, for first row, if we subtract, if we are performing in the row 1, what we are doing in row 1, we are performing the operation where we were subtracting row 2 from row 1. Okay, like 1 minus 1 will be 0, A minus B, it is A minus B, and that side will be A square minus B square. Okay, similarly if we are applying same scenario for row 2 also, we are subtracting row 3 from row 2, then we will get B minus C. Okay, it will be 0, it is B minus C, B square minus C square, and 1 C, C square. Okay, fine. Now you see 0, A minus B, A square minus B square. Sorry, if we expressed this A square minus B square with A minus B into A plus B, then just after that line we can take common A minus B from the first row, because in every element there is a factor A minus B. 0 is having factor as A minus B, from A minus B also we can take A minus B, and from this term also we can take. Similarly here also B minus C. Okay, and that case it will be B minus C into B plus C. It is 1 C, C square. Now if you take common A minus B from the first row, the first row is going to be 0, 1, A plus B. If you take common B minus C from second row, it is going to be 0, 1, B plus C, and the third row becomes same. Okay, now from that one we just have to solve. We just have to find the third factor, which is C minus C. Now it's very simple. Okay, look at, now we are applying that rule, or that finding how to find the determinant. For 0, if we remove that column, corresponding row and column, we are getting for 0, we will get 0, because 0 multiplied by something it will be 0. For 0 also it will be minus 0. Okay, or plus 0, anything. For 1, if you remove this corresponding row and column, you are getting like that. Okay, so it will be B plus C, 1 into B plus C minus 1 into A plus B. Okay, C, A minus B into B minus C, and here it is clearly C minus A, hence proved. Okay, you have to write these two things. I have applied these two rules in the same line. You can also apply it in different line. Now move to our next. I think this is the last question of previous years. Okay, similarly here we can also take the same motivation. Okay, here we have A minus B, so we can subtract this from that. Now here we have to subtract column 2 from column 1. Okay, like that. By applying these, we are getting actually A minus B, A square minus B square, and B plus C minus C plus A. Okay, here also if we apply, sorry, B minus C, B square minus C square, C plus A plus B, and that side it is same. what rule we have applied here? We have to write LHS. In previous question also you have to write LHS. We are performing on LHS. Okay. So we have applied, we have performed the operation in column 1. We have subtracted column 2 from the column 1, and for column 2 also it is same. We subtracted column 3 from column 2. So now see, it is a minus b. It can be written as a minus b into a plus b, and this is actually b minus c. Sorry, b minus a. So we can write it as minus of a minus b, because we are interested to take common a minus b. It is b minus c. It is b minus c into b plus c. It is c minus a, but if we take minus common, it will be minus b minus. Here it is same. So our next line, if we take a minus b common, and from that b minus c common, our determinant becomes 1 a plus b minus 1 b plus c minus 1 c square a plus b. Okay, now from that 4 factors we got 2 factors, a minus b in b minus c. Now we need c minus a. Okay, what factor we need? C minus a. Okay,